Thanks so much, Steve. That's awesome. Kia ora everyone. Good morning and welcome to our online session for our Saturday morning. Just a few little reminders about managing our chats and things. Hey, a little introduction about me. My heritage is from the Netherlands. Both my parents came to New Zealand in the late 60s and I was born soon after. I'd like to introduce my family. It's my husband Grant and my son Leo, who's in year 12 this year. Really fascinating being on the other side of the whole NCA experience. I live on the beautiful Waiheke Island, and a couple of things that I really enjoy is just getting out into the water, on boats, in my garden. But actually my kind of big purpose of life really is all about teaching mathematics and statistics, and that's taken me to some really interesting work at the moment, where I work as a PLD facilitator, supporting teachers in learning about mathematics teaching and how to get the best out of our students so that we have amazing young people going forward into their lives. So that's my passion, but really we all work to do something, right? To earn some money, and it's all about travel. So we're making the most of traveling around New Zealand. And down the bottom here, I've got a reference to the Solomon Islands. Quite a lot of my work at the moment is based in the Solomons, remotely, of course, writing maths materials for their primary school. So I'm really enjoying that. This will be probably the last year of that work, but yeah. So that's a little bit around about me. My background is in secondary teaching, as a head of department, assistant head of department, and just a plain old teacher, getting dirty with the actual stuff. And I truly miss it. Anyway, I'm going to get started with our talk today because I'm conscious of time. There's so much that I want to share with you. And today I really want to talk about this idea of learners are talkers, and that talkers can be learners. So let's get started. This is the little catchphrase that has really kind of interested my thinking in this space. The person doing the talking or the doing is often the person doing the learning. And I reflect on this as a teacher because I notice that in a lot of classrooms, the teacher's doing a lot of the talking. The other one actually doing a lot of the thinking as well. And it can become a little bit of a job of us trying to corral our thinking and navigating that to present to students. This triangle diagram was one that I first came across when I started teaching. In fact, I made a big poster for my classroom. And this is something I've really just come back to again. I think that this is a really critical idea of what is important when we're creating good learning. I've had to think about this last one down the bottom, teaching others, because I get a little bit concerned about turning our students into mini tutors in our classrooms. But what I think it's really saying is maybe it's when we ourselves have to explain something that we understand, that's the point where we can really retain what's going on. So a couple of other little things that I like to frame before we get talking about what does talking look like in the classroom is that we've spent a lot of time thinking about real world maths. And there's a real call for this, especially in the primary school. I can hear a lot of people saying, let's make it really real, let's integrate mathematics into other subjects. That's all awesome. I really enjoy that too. But I think there's a place for us to think about what maths is and the maths world specifically, which might be separate from the real world. So I quite like to use this cycle as a way of thinking about what we're doing in the classroom. So I certainly want to introduce things in the real world context. It's engaging, it's real. But from there, I want to take us through to the maths world, thinking about generalizing, extending, modeling, asking those what-if questions. Because when we play in the maths world, we can investigate and explore, we can look for new properties, we can find new generalizations. In fact, we can discover a new idea that then applies back around to the new real world. So if we think of something like calculus, where we might start with an investigation of speed and acceleration, we might think of rates of change, we might create a model for that rate of change, we might think about using our maths that we know to express a equation or some sort of mathematical representation, a graph, say, of that rate of change. Then we can explore that further, explore the idea of limits, have a look at the skills around differentiation, etc. And then it turns out, of course, that new skill that we've developed, or that new understanding we've developed in the maths world, reapplies to solve new problems in the real world. And I believe that we can find examples of this to be true in the primary sector as well. Things that start in the real world, create mathematical models, solve the problem in the maths world, and bring it back to the real world. So I think this is a really important challenge for us when we're working with our students, because sometimes we can spend a whole lot of time in the maths world without telling our students that we're in the maths world and that we will be going back to the real world. So hold that thought, because the next thing we really need to do before we start thinking about student talk is, what is mathematics? So if we think about the definition of mathematics, there's lots of different places you can go to decide what mathematics is. I really like this particular one. I came across it with some work with Sarah van der Werf in the United States. And I love this idea of exploring patterns. So starting with the noticing, taking it through to the describing, and working through to generalizing. And you can see how that relates to that mathematics world, real world, mathematics world cycle as well. Now, the answer to the question, what is mathematics, is really important, because it will affect how we approach our teaching and learning of maths. Other things which I base a lot of my work on is the best evidence synthesis, which is a massive volume to read and has a little summary that came out in 2009. Here's the 10 things, and it's a little bit like looking at a chocolate cake and going, yep, those are all beautiful things, but actually you need to kind of, really engage with these to understand what they really mean. I've sort of distilled it down to two big ideas. I think that the best is telling us two really, really important things. One is that we need to choose really worthwhile learning tasks. So we need to think about what that looks like, think about the cognitive demand. Is it low entry, high ceiling? That's a whole other conversation that we could have another day. So I'm going to leave that to one side, because I think that's a really worthwhile thing to explore. Today, what I want to talk about is the other thing that I think comes out of those 10 big questions, is how do we have mathematical discussion and talk? How do teachers manage a classroom discussion? How do they support children or students to talk and grow their thinking? And how we can ensure that there's equitable participation? So let's get into that. So this is this idea of student discourse. It is an essential part of our maths learning. When students share and exchange, there's a benefit for both the teachers and for the students. For the teachers, it's about us having a little bit of a window in on what's happening in the student's mind. So we don't want to just assume that what we've transmitted has somehow ended up in their brain. After all, it's not a flip-top head scenario here. So when we get students to talk, we can listen in on what they're doing and thinking. To create a rich environment for discussion, we need to choose tasks which allow rich discussion and a variety of approaches. There's this idea of orchestrating the class, so seeing ourselves as conductors, if you like, bringing in one person and another person, finding ways to have a norm in our classroom so that there's this opportunity for everybody to talk and getting that timing correct. It's about giving students tools to learn about how to discuss and listen. I've captured that in two words, really. Teacher moves, what are the things the teacher needs to do? And talk moves, which are the things that the students need to learn how to do, how to add on to something, how to rebuttal an idea, how to negotiate that conversation so that they're doing that great mathematical talk. If we think about what productive talk looks like and what we need to do to have productive talk, we need to make sure that we have a mathematical goal. So I'm not talking about any old talking happening in the classroom. We know that plenty of students want to talk, but I want there to be a real mathematical goal for the talk. The students need to know what and how to share so that their ideas are heard and useful to others. And this is really about teaching them that negotiation of how to talk in a useful way with other students. Our job as teachers is to orientate the students to each other. So this can be a challenge because we often orientate the students to us, right? We sit at the front, all the students face the front. So we need to find ways of orientating the students to each other, whether that's through occasional group work, through peer work, through all the time being in groups, things like that. We need to actually make sure that the instructions are clear, that students need to talk with one another, not just to the one person at the front of the room who holds the power of the room. Teachers need to communicate that all students are sense makers. So we're not just valuing the opinions of our top students. We're not just trying to draw out our most vocal students. We're really understanding that everybody needs to make sense through that talk. Now, when you get the slides later on, there are references to all of these bits and pieces. I'm going to share with you the actual PowerPoint so that you can see the notes below, because almost each of the following slides I have little references and website links to have a look at so that you know for future. So let's have a think then about why it is that it's so hard to get students to talk during our classroom interactions. And essentially it's this: students are afraid to be wrong. For many students, talking in a maths classroom feels like this, being on an edge and being scared of falling off over that edge. So we need to find ways to find safe ways for students to enter into a mathematical task. Now, these ideas come from Sarah van der Werf. I saw an amazing presentation during lockdown that she did to explore these ideas. And so I've taken the format of her workshop and just changed it around a little bit to explore different problems that I think will be relevant for our classroom curriculum. So what I'm going to do in the next part of this presentation is to take these 8 different ideas one at a time and show you how we can use these as little routines within our classroom to create mathematical talk. So the first one is, what do you notice and what do you wonder? Now, with the goal for all of this, actually, if I just go back to the previous slide for a moment. So if we just think about these 8 routines, our purpose for doing these routines is this planning goal. So we want to plan that students will see the maths before we show them. And we want students to say it before I tell them. In other words, we need to help students to see what we want them to say. Now, a lot of the time we can get caught into this part here, the showing and telling. How often have we walked past a maths classroom and seen the teacher at the front showing the students how to do it or telling them how to do it? So I'd like to challenge us all to plan more to get students to see something so that they say it, because that's the place where we know they have some understanding. All right, so let's zoom in now into what do you notice and what do you wonder as the first routine. Okay, so have a little moment to have a look at this diagram here, or this photograph, and what do you notice and what do you wonder? Some of the things that I notice is there's lots of counters, there's 2 different colours. Students will say things like, are there 2 bags in each of these piles? I wonder how many piles there are. Some students might notice that there's 5 rows and 10 columns. And then, say, in a primary class, we might talk about how many piles there are altogether, how many plastic bags, how many counters might there be. So this could create quite a rich discussion. So the starting point is, what do you notice? What do you wonder? And as a teacher, our teacher moves are to welcome all of those ideas and write them on the whiteboard without judgment. So write up every idea, any idea, even if it's something that we might not be able to answer from the picture. It's really about getting students to risk asking their question, even if they do or don't know an answer. And then from there, our job is to select 1 or 2 of those questions and explore those as to find the answer using the information that we have in front of us in the diagram. Here's another one. What do you notice? What do you wonder? What sorts of things might students come up with? It's really interesting when I hear students talking about this one. Many of them at first don't connect the little bags of balls with the number line running across the top. So I encourage you to put this up and give it a little bit of time, get students to pull out different ideas, write them up, keep drawing out. Often with this, if it's a stony silence, the question to keep asking is, what else do you notice? What else do you notice? What else? What else? What else? And keep drawing out those ideas. Could we draw another one? Could we draw some bags to go in between? You know, intersecting other questions into this. This could be something that we use at the beginning of a probability topic, not at the end, as a way of stimulating the conversation around what is probability. There's plenty of animations. Now, let's see if this works. I'm not sure if it will. No, I think it won't. So, and again, and when you get these slides, there'll be, oh, maybe it will work. Are you seeing this? Yes, perfect. Let's see if the internet is stable enough. Yep, here we go. So lots of little animations you can find online. Again, there's links to all of these in the slide, and plenty of other animations for different topics. So you can see there, I'm going to just take that back so that it doesn't run. So we can have great conversations. So rather than just saying, okay, today we're doing the exterior angles of polygons and just, you know, batting out the rule, what about actually getting the students to decide what the rule is for the exterior angles of polygons based on this little animation? And using the what do you notice, what do you wonder as a way through to draw the students' thinking out. Some primary teachers might be familiar with this idea of choral counting. It's something I've only just discovered in the last little while. So this is about writing a sequence of numbers up on the board in rows and columns. So this teacher has started with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and then just ask the students to, what do you notice? What do you wonder? The teacher's written up these things on the board, lots of amazing little patterns coming through. And then the teachers asked, well, what would go in this box here? How can you tell? Cool things about skip counting, about looking for patterns, running diagonally as well. Students will notice patterns running diagonally. So this is something that might be in a year 2 classroom, but here's an example that might be in a intermediate or junior secondary school classroom where we've got fractions. So the teacher started with 1, 6, 2, 6, 3, 6, etc. through to 6, 6. And all the way through, and you can see all of the amazing things that the teacher's written over the top to get the students to express the patterns that they notice in these things. And we've got that rich conversation going on about different fractions, how we say fractions, whether they're equivalent, how do we describe the patterns going through. Again, there's a really cool link and a couple of videos of how to use choral counting in your classroom. Totally recommend you looking into that, and different ways of varying it. So sometimes you might want to not stop at 6, 6, but say go 1, 6, 2, 3, 4, 5, 6, and then start 6, 6 on the next row, and you get different patterns. So there's lots of things to explore as a starter for great discussion and conversation. Few tips about using I notice, I wonder. One way to explore these is to just remove some details. Now, this is a really boring problem from a textbook, all about rates and ratios. And when you look at a problem like this, it's like, I don't want to do it. It sounds really boring. So what about changing this question around and just starting with some visuals? Here's an example. All of that same problem can be answered just starting with this picture of some porridge and a table, and asking the students, what do you notice? What do you wonder? So the first thing they might think about is, yeah, I think I've made some porridge. What might it be? What might go in here? Water and oats. And then we have some relationship between the amount of water and the amount of oats. What could go in here? Let's talk about it. Let's think about it. Let's play with ideas. So we can start with a really boring problem and just strip back all of the information, add a picture, and find a way into the problem in a different way. Here's another absolute favourite of mine. I subscribe to a website called Daily Overview. Every day they send me a picture from some sort of overview picture. If I was in a workshop with you all now, I'd be asking you, could you tell me what this is? Any ideas? bit hard for us to talk because there's so many of us that probably it's easier for me just to lead you through. I love the symmetry of this. I want to be able to talk about the different symmetry and things. It's actually an airport. It's an airport in Indonesia. So there's a little bit of information there. And these little white dots, I'm not sure if you can see them, are aeroplanes. We could talk about scale factor. We could think about how big it is, how big is the airport. We could talk about how long it might take to walk from one terminal to another, etc., etc. So airports seem to have amazing designs. So there's quite a few airports that come up in the daily overview web page. All right, so let's get into the next routine. Which one doesn't belong? And lots of people are familiar with this already, but I'll introduce you to a couple of my favorites. So the idea with which one doesn't belong is that you get 4 pictures, and the students need to discuss why does one of these not belong. So, for example, I might say that this one doesn't belong because it's the only shape here with 5 sides. This one doesn't belong because it's the only one that's been shaded grey. So the idea is that the student will think of a reason for each of the 4 shapes and discuss all of those. I love the range of problems. We've got ones here to do with spinners, time. There's ones to do with number, graphs, equations, and we've also got things to do with fractions and things like that. This one's come from a different source. They've labelled the corners A, B, C, D, which is quite handy for getting students to talk about which one it is that they're talking about at any one time. I think it's also a lovely challenge to get students to make up their own which one doesn't belong problem and to present that back to the class. You want to create some movement in your room? We could also label the 4 sides of a classroom with the different corners of the which one doesn't belong and get them to move to the different sides of the room and then move around the room asking students to talk about why have they located themselves on that side, what's their rationale, has everybody standing in that same place got the same reason for why it doesn't belong. Here's another routine which we can use to get students talking. What is the same? What is different? There's a whole website of these. Again, the link is online. I really particularly like this particular problem because protractors seem to be such an issue for students. How to navigate reading through a protractor seems to be an issue. So maybe we can talk about why they're different and what's the same about them. We can also talk about other different curriculum areas. We've got lots of different examples here. So one to do with fractions, what's the same, what's different with each of these. What's the same, what's different here? Something that seems to come up as a confusing issue in lots of junior classes. Here's a equation expressed as a diagram and an equation expressed in its algebraic form. What's the same, what's different? Thinking about units of measurement. Here's an idea for exploring a definition. So instead, we're so tempted, aren't we, to just write up a definition. Here's a definition of a polygon. But what about swinging this around and actually saying, here are some shapes which are polygons. Here are some shapes that are not polygons. Based on what we see here, can you write a definition for a polygon? So we're giving the ownership back to the students for them to negotiate what a good definition is. And then at the end, we could throw up the definition and see if it matches, see if we need to interrogate our class definition next to the official definition. So there's lots of different ways that we can use this. What is the same? What's different? I think there's some work around concept development where when we discuss what a concept is, we need to show examples of that concept, but also non-examples so that we can clearly define the limit, I guess, of the definition of what is included in that concept. Would you rather is another way of exploring something the same or different. So imagine if I have a cube of gold, 25 meters on each edge, or if I had 2 cubes of gold, which one would you rather have? So what I like about these problems is that they're usually something that you can't just look at and know the answer. There's some more discussion and debate that needs to go on. Here's a website full of these examples. Here's a probability one. Here's one that we might use in a primary context. Which one would you rather have? 5 rows of 14 chocolates or 5 rows of 9 chocolates? So good debate for kids to, talk about which one they would rather and to justify their thinking. On to our next routine. Tell me everything you know about. Here we go. What about if it's just something as simple as point 4? Tell me everything you know about it. Well, here's an example of a teacher's exploration with a primary classroom. Point 4. And you can see that there's 2 sets of writing here. So the teacher's first of all written in blue everything that the students wrote. And then later on, they've critiqued it and discussed it. So there's been some commentary added in pink. So is it even? Well, I'm not sure really. Is it can a number less than 0 or less than 1 rather be an even number? There was some disagreements. So somebody talked about rods. So that, with our place value rod, that usually represents 10. So these people have disagreed that actually they wrote it up as 4 rods, but they've disagreed. They think it's a fraction. So you can see that there can be some negotiation. We're just going to include everybody's ideas to start off with. What about in a secondary context? Tell me everything you know about. Now, I wonder if you can guess what the first 5 things that students will say about this graph. Yep, it's red. Then they'll say it's a graph. They'll say there are numbers on the graph, curve, and axes. But if we keep pushing, we're going to start to hear some other things. We'll talk about this maximum value, where it crosses the y-axis, x-axis, maybe the shape, etc. So I think what this demonstrates to us that sometimes we need to keep pushing and keep asking that question, what else, what else, what else? And then we've got some information that we're getting from the students about what do they see when they look at a graph like this, rather than always being driven by listening to what we say about the graph. Now, another favourite for me is slow reveal graphs, which is a format of graphs or statistical graphs where almost all of the information is taken away. And I've just created a little slide, a couple of little animations to add in more details. So you would start off with something like this and ask the students, what on earth could this graph be looking at? And they look a little bit like milk bottles. So maybe they're thinking, oh, I noticed here that there's 5 different parts of the graph. Maybe this is Monday, Tuesday, Wednesday, Thursday, Friday. What else could it be? Let's have a think. And then the next click, I get a little bit more information. So now we have some information about water used. Okay, are we still thinking these might be days of the week? Yeah, they might. What might be in this box here? Okay, click it again, and now we've got it's 1 gallon. Now, based on this information, we'll be wanting to change what we know about this graph. And slowly, I can drop in more information. The next slide shows me that this is to do with water uses in the home, and that this one is using sink faucets, obviously an American example. So we might then have a discussion about what could these other things be. It's not days of the week, so what could they be? We might draw out from the students what they think their experiences are of water use in the home. Here are a few more dropped in. What might this last one be? Flushing the toilet and other. Then there's usually some information about where the graphs come from. So this is a way of getting students to really make sense of data and look at graphs. The link is in the slides, as I said. There's lots of really amazing examples. They take you through to a Google slide, which you can download. And each of the notes underneath tells you about some questions that you could ask your class to really draw out their thinking. So totally recommend looking at these slow reveal graphs as a way of getting students to interrogate graphs more fully. Estimation is a way to get students talking as well. Estimation 180 is a website with hundreds of different diagrams or pictures to get us started. So here we have a bowl with some cheese balls in it. How many cheese balls? Let's debate it. Let's discuss it. Another example, some of them come in the form of a little video. So this one, and often you have to show these videos a couple of times to get the students to really think about what their maths is that they can draw out of this. We might pause it at some points as well. Poor zebra is going to get it. So and then we would stop there and perhaps ask the question, what do you notice, what do you wonder? And draw out some lovely measurement questions around, I wonder how long it will take before the zebra falls off its perch. How can we estimate that? Can we use a timer, watch the video again, maybe look at how far, make some estimates of distance, have a think about speed, acceleration. All of those things could be drawn out of that little conversation, getting the kids to talk through what their method might be to solve the problem and estimate the answer. So again, there's lots of different videos and draw pictures on that website, Estimation 180. Why is the solution correct is another way of getting students to talk and get them to get used to talking in the classroom. So here's one, the old debate with the protractor again. Is the measurement 35 or is it 145? Who can convince me who is correct? Here's another one. Which fraction is in the wrong position? So we're kind of giving our students a leg up here by saying that there is one in the wrong position, and now it's all about just working out which one isn't in the right position and justifying it and coming and explaining to each other and then perhaps to the class. This is one that's obviously a real bugbear for us in algebra as well, where we see all sorts of random, well, not so random, but random nonetheless, cancelling going on. Of course, it works for this one, but convince me, is it true? Is it always true? Can you find another example where it's true? Can you find me all of the other examples where it's definitely not true? Why is it something we can't cancel in this way? Again, there's a website with somebody's created hundreds of different convince me that questions. Here's one that I've just snipped straight off the website. Convince me that a square is a rhombus and a rectangle. So I'd propose that a student who can convince me that's true has really negotiated the definitions of squares, rhombuses, and rectangles. Here's another one for primary context. Convince me that 110 is the same as 10 ones. I might use equipment to explore that idea. Convince me that 4 can be greater than 5. And convince me that the area of the shape below is 9 square units. So it's not just kind of getting students to do a problem, but rather they're being asked to really express how they solve the problem. And of course, in the MCAT, we've seen these kinds of questions being used in an assessment. So where students need to show their reasoning to say whether Francis is correct or not. So it's quite a nice way of exploring more of a mathematical reasoning in an assessment task as well. So we need to get students used to doing that in their day-to-day practice and not just being faced with a problem like this in an assessment and not knowing how to get started. Lastly, we can use storytelling as a way to get students talking and thinking. So here's an example. We've got a screenshot of a phone. Maybe we could put a story to this problem. We've got a phone that's only 5% charged. I think we can tell it is on charge now. Is it at night? How can we tell? What are all the cues that we can use from the screenshot to make a mathematical story that relates to how we got to this position? What happened before this phone got plugged in? Here's another one. We've got a coffee. A small coffee is $5. If I say, small coffee, please, my coffee is only going to cost me $3. If I say, hello, 1 small coffee, please, I only have to pay $1.75. So can you justify for me what the cost would be if I say, hello, 1 small coffee? Or could we create some other scenarios like this and to think about the cost of our copy, different ways of getting us to talk and think mathematically? So I want to return to our planning goal, which was to say, how can we get students to see something before I show them? And how can I get students to say it before I tell them? So what are the ways that we can use different routines in our classrooms to get students used to seeing what we want them to say? Obviously with the intention that they can understand and express what their thinking is as they're doing their mathematics. So really, we want to be supporting our students off that ledge, really. How can we support them so that that doesn't feel as scary as being on the ledge? Our moves as teachers is to listen, to prompt, to evaluate progress, but mostly to be quiet more often in our classroom and getting our students to talk more so that we can listen to their thinking. Those 8 routines might inspire you to try some different things in your classroom to get some students talking. And remember that this idea starts with, or mathematics thinking starts with noticing, first of all, then being able to describe it, so using some words to describe, and then to generalize, so that we've really got a rich and full understanding of what mathematics is. If you're interested in finding more resources like that, I've put them all on the website, mainly because I have trouble remembering where they all are myself. So mathslink.org is a website which has plenty of links, heaps of different links and thoughts about where to find different material and ideas, and I've linked in some of my favourites. So as we finish up the session today, I'm wondering, as you think about what we've talked about today, what are some things that you might start doing? What are some things that you might stop doing? And what are some of the things that you already do in your classroom practice that you're going to keep doing? So if I was running a face-to-face meeting, we'd share those things around the room. So maybe if we've got time, we can do that depending on how many people are here today. If you're interested in exploring some of these ideas some more, there is regionally allocated PLD hours available to all New Zealand schools. The closing dates, there's 2 more closing dates this year. I'm really happy to help you if you are thinking about a maths PLD project in your school. Perhaps you want to implement some of these ideas into your classroom. Happy to help with that. And here are our finishing slides for the AMA session. So yeah, Megan, is there anything else? I'm not even sure where we are with time.
Oh, tēnā rawa atu koe, Julia. Thank you so much for that. 5 minutes for questions, Q&A. I really enjoyed your talk. Thank you so much for sharing all that with us. There was one question from Kristen who asked if the website's links referred to are supplied in the PowerPoint that you're going to share.
Yes, yeah, they are. And I've just embedded them, put them into the notes part. So I won't send them as a PDF, I'll send it as the actual PowerPoint so you can get in and see those notes and things as well. Yeah.
That's great, thank you. And all the links to the PowerPoints and the video recordings will be shared via email. So if you've registered for the session, you'll get notification of when they're accessible. Just scanning through to see if there's any other questions. None coming through yet. I just wanted to make the comment that I really enjoyed listening to that reinforcement of the importance of student talk and the you know, ensuring that the talk is productive. And I've always loved the sort of notice and wonder approach, you know, the 3 acts of mathematics. And I also like the idea of exploring those multiple representations. So thank you for highlighting all that for us and ensuring that we're sort of bringing more criticality into our mathematics and statistics lessons, and lots of resources there for us to look at. Are there any questions? People can just jump in, unmute and jump in with a question if you have one. Tessa.
Yeah. Could you please explain more about the regionally allocated projects to our school that you just, you know, described in the second to last slide, I suppose?
Yeah, absolutely. So the Ministry of Education, they have a PLD fund, which is distributed across schools. And they have 4 dates per year where teachers can, or schools can apply for that PLD funding. That pays for a facilitator, someone like myself, to come and work with you in your school. Your school would design, probably with the help of a facilitator, some sort of PLD project. So, for example, I work quite a lot with schools that are getting rid of their streaming in their classes. So they've got mixed ability, or I prefer to say mixed attainment classes, or students working at lots of different curriculum levels. And how can we enrich our teaching so that we can include all students in that productive talk and productive thinking? So we would design a little PLD project for your department or your school, and the hours would get paid for by the ministry. So there's still costs involved for the school, things like release time and, things like that. But yeah, so there's a website to go on to, which is part of the slides. So totally recommend having a look at those. Yeah, or just contact via email, and I'm happy to point you in the right direction. It's a little bit of a navigating through the ministry resources. So
yeah, it might be confusing. But
yeah.
Thanks.
All good. Any other questions? Cool. I can see somebody else saw the Sarah van der Werf session. It was really amazing. Maths Moment Summit. That's another, actually that's coming up again in the next little while. Building Maths Matters, something like that, and where it's they run a webinar like this, actually, beautifully run as well, and lots of really amazing ideas. So worth registering. It's free for 10 days.
Great, lots of information and lots of future things for us to look into. Thank you so much for that. Thanks, Robin. Build Maths Minds is on July 30th, apparently. Well, thank you once again, Julia, for spending the morning with us. Really, really worthwhile, especially when we can take so much away and sort of look at our practice again. Or maybe it's reinforcing that we are doing the right things. So thank you so much.